So we discussed that factor affecting the refractive index of a medium. Okay. So continuation of previous topic, factor affecting the refractive index of a medium. The RI of a medium Okay. So first factor is called it's a nature of the medium. Is a nature of the medium. Okay. So first, actually, nature of the medium is basis of speed of light. Right. So actually, you know that very important. If you have more velocity, you should discuss here. Actually, okay. So more velocity means less refractive index, or less velocity means more refractive. Suppose take an example. If you consider the mu of glass is a 1.5. 1.5. So velocity of light in glass, V in glass, that is 2 into 10 to the power 8 meter per second. Okay. So if mu of water, that is 1.3. So actually, so speed of light in water, that is uh, 2.25. So see that here the velocity increase or mu is decreases. So 10 to the power 8 meter per second. Okay. So actually refractive index is depending on basis of speed of light. And next concept is nature factor is a physical condition such as temperature. Very important. So more temperature means, okay, see, if more temperature means speed of light is increases. Okay, when temperature increases, speed of light is increases. Okay, so actually more temperature increases, so temperature increases. This means speed of light also increases. Okay, the speed of light is increases, so mu is decreases. Okay. So actually, so vice versa, if temperature is decreases, speed of light is decreases, so mu is increases. Okay. So last factor, another factor is the color or wavelength of light. Color or wavelength of light. And wavelength of light. So you know that a VIBGYOR, VIBGY OR is VIBGYOR. So we know that the violet is a less speed. Yes, less speed, red is more speed. Okay, red is more speed, violet is less speed. If so, less speed means more RI, and that is if speed is increased, less RI. Simple. So we tell that if that conclusion here. So velocity of violet color okay, is less than velocity of red color. So mu of violet is more than mu of red. Okay, clear. So actually see that is velocity and RI, they are inversely proportional, previously discussed. Okay, so clear. So more effective index means less velocity, and less effective index means more velocity, or more velocity or more speed. Okay, actually we discuss only magnitude. Okay, next discuss the principle of reversibility of path of light. Principle of reversibility. 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 The path of light. So first we draw a diagram. There is this line. We try to draw a straight line. So I have to consider that is a straight line. Okay, that is a incident ray, point of incident. Here is the normal. So that is a reflected ray. Okay, so suppose that is a medium 1, that is medium 2. I consider, let's say medium 2 is greater than medium 1. So actually light travel from rarer medium to denser medium. So that's why refracted ray bends towards normal. So refracted ray bend towards normal. Okay. So that is incident ray, reflected ray, and that is called refracted ray. Refracted ray. Just short form. Okay. Incident ray, reflected ray, and refracted ray. So that is I incidence angle, R reflected angle, and that is R dash, that is a refracted angle. From we know that mu 1 to 2, mu 1 to 2, light travels from one medium to two medium. Okay, from rarer medium to denser medium. From Snell's law we know that is sin I by sin R, sin I by sin R dash refracted angle. Okay, if reversibility means if a light travel from backward from source here, so light travel from denser medium to rarer medium. Okay, so light travel from denser medium to rarer medium. So bends away from now normal, refracted ray, that is a refracted ray, that's condition, that is incident ray, that is refracted ray. So that is sin I means sin R dash, that is that's what that time that angle is the incident angle and that is a refracted angle, and that is sin I. Okay, okay, that is the principal reversible. Back path also satisfied. Okay, now if we multiply these two, okay, multiply these two, that is equation 1 and equation 2, mu 1 to 2, mu 1 to 2 multiply mu 2 to 1, So sin I by sin R dash times sin R dash by sin I. So they cancel, get 1. So reversibility property, they are reciprocal actually. Mu 1 to 2, that is equal to 1 by mu 2 to 1. They are reciprocal. Okay, clear? Very easy concept. Yeah. Okay, prove that from Snell's law. Also similar type of proof, also speed of light concept. Okay, method another to the mu 1 to 2. So speed of light in medium 1 by speed of light in medium 2, and mu 2 to 1 means speed of light. So another method, light in medium 2 by, you know that, okay, previous classes, speed of light in medium 1. If you multiply these two, so mu 1 to 2 time mu 2 to 1. Suppose that is a V1, say that is a V2, and that is say that V2 by V1. So V1 by V2 and V2 by V1, all cancel these two, get 1. We get the same concept. Mu 1 to 2, that is equal to 1 by mu 2 to 1. Same. If I consider this. And if you solve another technique method is if you solve that help of mu, only mu 1 to 2. Another method. Okay, reversibility property proof. A mu 1 to 2 means refractive index of medium 2 Ri of mid 2 by Ri of mid 1. So 2 to 1 means mu 1 by mu 2. If you multiply these two, 1 to 2 times mu 2 to 1. So mu 2 by mu 1 times mu 1 by mu 2 cancel. So you also get 1. So mu 1 to 2, that is equal to 1 by mu 2 to 1. Okay, that is 3 methods. If we consider the relation between mu to incident angle and refracted angle from Snell's law, from speed of light of medium, another method is called speed refractive index of that medium 1 and medium 2. So both are satisfied that reversibility property principle. That is the principle of reversibility. All are satisfied actually. Okay, so actually they are reciprocals. Okay, if mu 1 to 2 and 1 by reciprocal 1 by mu 2 to 1 means that is reciprocal of mu 2 1. Okay, mu 1 to 2 reciprocal. Okay, clear. Next we discuss that lateral displacement. So it is called lateral displacement. Lateral displacement. So what is lateral displacement? First we consider a glass slab here. Okay, there is a glass slab. Okay, so there is a medium 1, that is a medium 2, and that is also medium 1. We say that the medium 2 is more denser than medium 1. Okay, so light travel from rarer medium to denser medium. If light travel from rarer to denser medium, that is the incident ray, and That line represent normal. That is a point of incidence. Okay. So light travels from rarer to denser. So that is a path, straight line, light traveling straight path. But due to the mismatch of the density of the medium, so light bends towards now because the light travels from rarer to denser medium. So bend towards normal. Okay. If we consider this is a path, okay, this is a path, a line of incidence. Now we consider this is the boundary of line of incidence. So now at that condition, light travels from denser medium to rarer medium. From denser to rarer medium. Here light travels from rarer to denser, and here denser to rarer medium. So this is a point of that's point of incidence. Now draw a normal. That's a normal, and light from denser to rarer. We know that refracted ray bends away from normal. So that's why normal. Okay. So if that is considered a glass slab, if that is a glass slab, if that is a glass slab, a glass slab, glass slab, slab. So that is a incident ray. That is a refracted ray. Sorry, refracted ray, and that's also called emergent ray. This ray is called emergent ray. And if ray of light traveling straight path, if m1 m2 both are in same density, so light travel this path, this straight dotted line path. So actually that is a deflection. Okay, due to the deflection, and if I draw a point here, draw a perpendicular from that point. If I draw a perpendicular from that point to emergent ray, if I draw a perpendicular from to emergent ray, sorry, perpendicular from emergent ray, get it. This angle is 90 degree, and so that is a displacement. Actually, if both are, if not glass slab here, the light travel in straight path. Actually, the light travel in that straight path, but due to that glass slab mismatch of density, so light travel here. So here is a displace. So that displacement is called lateral displacement. So this displacement is called lateral displacement. Okay. This distance is called lateral displacement. Okay. Some factor is depending on lateral displacement. Some factor is depending factor. First is the thickness of the medium. Thickness of medium. If that thickness is y, okay, more thickness is more lateral displacement. So they are directly proportional. The lateral displacement is called x. That is called x. So more thickness means more lateral displacement. Okay. Next factor is angle of incidence. Angle of incidence, I. This is the angle of incidence, and that is called R, refracted angle. Now that is called I dash, and that is called emergent angle E. That is a emergent angle. Okay, we say that is R and that is equal to I dash. Okay, from right, these are the alternate angle. Alternate angle. Because these are the normal, these two normals actually they are parallel, and this line is called a sector. So that's why these are called alternate angle. Okay, and if an emergent ray parallel to incident ray, and also the emergent ray is also parallel to incident ray. Okay, so that's why I also E. Okay, so angle of incident dependent. If angle of incident more, emergent angle also, sorry, lateral displacement is the uh, more lateral displacement actually. Okay, so that is also proportional to x. Next, third, number 3 is called the refractive index, depending Ri. Okay, that's very important. Um, so it's more actually, if I consider violet ray, violet and red, Vibgyor. Okay, okay. So lateral displacement more for violet than red. Violet is more lateral displacement. X of violet is more than x of red. Why? Because we know that here, see that if means because more Ri, violet has more Ri, red has less Ri. So here that is a mu of V is greater than mu of R. Why? Because that the velocity, see that, okay, actually see that if velocity of red is more than velocity of red is more than velocity of violet. So refractive index, if more velocity, less refractive index. If less refractive index means less lateral displacement. Okay, that is a easy concept. Okay, so lateral displacement of more of violet than a red light. Very easy concept. Okay, so if you see that here, concept. That is a concept. Okay, clear. So in this the first part of the refraction of light. Next class we discuss second part of the refraction of light in a surface. The second part is um, refraction of light through a prism. Okay, so end the class here. Thank you.